Here's the next example, example 4. In this example, we need to evaluate the integral of 1 over the square root of x squared plus 4 dx. The reason I brought this integral is the following. Because this business of trigonometric substitution is so impressive that you may jump into substituting x squared plus 4 with the tangent, because this is in the table of trigonometric substitution. That will be the substitution. However, if you look carefully, and I lied to you, let me change that. It's x over this thing, like so. Okay, my bad. It's x over. Now, here, instead of using trig substitution, actually you have an easier way, because if you look carefully, the numerator read x dx, and 2x dx is the derivative of x squared. So here, using the standard substitution will be easier than the trig substitution. Okay, so let me write a comment. Instead of using the substitution, x equals 2 tangent theta, observe or use the substitution u equals x squared plus 4, and the reason is the presence of x squared dx. So every time you have a function, the derivative of a function is part of the integrand, you want to use the standard or the easier substitution. Okay, so for instance, du going to be 2x dx, and x dx will be simply replaced by du over 2. Okay, and we have x dx on top, so the integral now looks like this. So I'm going to write it now as x dx is simply going to be the integral of 1/2 du over the square root of u, like so. We're going to write it 1/2 the integral, and this would be a u to the power of negative 1/2, like so. The antiderivative, do you remember what happened here? We add 1 and divide by the result. It would be 2u to the power of 1/2, like so, plus c. So this is an easier deal here. We need to back substitute u, so you end up having the 1/2 and the 2 cancel each other. U is x squared plus 4, so you end up having the square root of x squared plus 4 plus c. A much quicker exercise. Indeed, we did it at the end of chapter 5 when we learned the integration by substitution. If you remember, I believe it to be section 5.5. At the very beginning of the semester, I did a little review of chapter 5, and we had that particular example.
For that one, would you like try setting the integrand equals cosine theta, and then drawing the triangle?
For this one?
Wouldn't that work?
No, I tell you why. The question was, can we set up the integral to be cosine theta, right? The answer is no, because cosine theta is a value between -1 and 1. The x here, when you have the x squared plus 4, the square root of x squared plus 4, x can be any value from -∞ to infinity. So this will be improper. You artificially restrict the domain of the variable x by choosing. So that's why we chose these three particular substitution B, because we can produce values of x that meet the range of the function. But it's a good question, nevertheless. It means that you cannot just go and arbitrarily use the trig substitution.